Hello everyone, welcome to our channel The Education Seeker, and this is my second problem on batch reduction and it is of MCQ type. There are 4 options, option A, option B, option C and option D. Now coming to the reaction, this reactant molecule is basically representing an alpha beta unsaturated carbonyl molecule from this side and also from this side. And you know, in an alpha beta unsaturated carbonyl molecule, only double bond is reduced in presence of lithium and liquid ammonia and the keto functionality remains as it is. Now, as you can see in option C and option D, both the double bond and the keto functionality are reduced simultaneously, right? But that is not correct. So we can eliminate option C and option D. So out of 4 options that we have, we are only left with option A and option B. In option A, this double bond is reduced, and in option B, this double bond is reduced. So basically, selective reduction of the double bond is happening. And to know what is the reason behind the selectivity, the mechanism of this reaction has to be considered. So now, so far the mechanism is concerned, in the first step this molecule in presence of lithium, and lithium is basically involved in single electron transfer process. So an electron is added to the alpha beta unsaturated moiety and this radical anion is generated, and in this radical anion this radical can undergo resonance with the remainder of pi system, and simultaneously these 2 canonical structures are formed. Now in the second step, in presence of lithium, another electron is added to the radical anion and this dianionic intermediate is formed in the reaction medium. Now in this dianionic intermediate, this carboanionic center can undergo protonation or this carboanionic center can undergo protonation. Now the important thing is that the protonation step is completely driven by the presence of hydroxyl group. And this hydroxyl group is above and the hydrogen is below. And this carboanionic center is accessible to this hydroxyl group, but this carboanionic center is far apart from the hydroxyl group. So as a result of this carboanionic center abstracts a proton from hydroxyl group, which is intramolecular process, and this dianion is formed, and in the last step it further undergoes a protonation and this product is formed in the reaction medium. So the correct answer is option B. So now this is the complete scenario, but the question is what you can get out of the problem and what are the observations you can make while solving the problem. So this is really important, how you can implement your ideas in the field of research, right? So here are some important points that you can make out of the problem. The first is selective reduction of a particular double bond is driven by the presence of hydroxyl group. Second, any double bond in the reactant molecule can be selectively reduced by monitoring the stereochemistry of hydroxyl group containing carbon. That means if this hydroxyl group is in the below, then instead of this double bond will be selectively reduced, right? Third is a new chiral center is generated in the product molecule. So this is the new chiral center along with this and this. And the fourth is intramolecular protonation. Now if you are a synthetic chemist, you can argue that there is no role of hydroxyl group in determining the stereochemistry of the product. And also you can say that protonation is happening or occurring from ammonia molecule instead of hydroxyl group. So basically you can do 2 experiments. The first one is like that. In this molecule you can deuteriate the hydroxyl group. So if the protonation is intramolecular, then scrambling of deuterium will happen and deuterium will be attached to the beta position in the product, and this green color hydrogen will be from ammonia. And now the second experiment you can do, you can deuteriate the hydrogen of ammonia molecule. So if the protonation is intermolecular, then red colored hydrogen from hydroxyl group will be attached to the beta position in the product, and this deuterium will be coming from ammonia molecule, right? So this is all about this problem. So thank you very much for watching, and please follow our channel, The Education Seeker. And if you are completely new to our channel, then please subscribe to our channel, and we promise to give the best out of us to update you in the field of chemistry. So thank you.